All right, guys, welcome back. Grab a pen and a paper. You guys are ready to go because today we're going to talk about architectural patterns and a hybrid and multi-cloud secure networking architecture. Uh, Again, these are based on Google Cloud's current cloud architecture center. You know, I'm also going to touch base on cloud AI, Google Cloud for AI. And then I'm going to get into the different patterns that there are and handover patterns, especially when you're designing those. Again, Google Cloud for AI, it's one of those leading platforms for building, either you train, you deploy AI, and you got to learn the machine learning, so the ML application, right? Um, like I said, this is all provides ready to use AI tools and has different advanced foundation models for you to go. It lets you train your machine learning models in different main AI platforms, and then I'll get to the generative AI. But if you let the trained machine learning models are in Vertex AI, which is our Google Cloud Unified AI development platform, deploy models to production and monitor performance. Right. So we'll get to the Gemini models. We'll also get to the pre-trained models. We'll talk about when we can use them in Vertex AI. And we'll also talk about pre-trained AI infrastructure, BigQuery, MLOps, and when you should use Google for cloud AI. I want to welcome you guys back to my channel. And if you're new here, hello. Whether you're a beginner exploring machine learning, you're a developer building an A-powered app, or just a business looking to scale with generative AI, Google Cloud offers powerful tools, right? And like I said before, just a couple seconds ago, Vertex AI, advanced infrastructure and access to cutting edge models, right? So keep in mind, Google also has something called DeepMind. In this video, I want to break down what Google Cloud AI is. I want to also talk about BigQuery ML, Vertex AI, and how generative AI fits into the ecosystem, and why you as a business are choosing Google Cloud for AI. If you want to choose Google Cloud for AI, you choose it if you want an infrastructure that's scalable. Right? You also want to need the enterprise grade security when you're choosing. You also need to build a production AI system. And you also want to know why the business, like I said before, why the businesses are choosing the Google AI, right? So you want access to Google's foundational models. Again, if you're building a startup, you're preparing for a cloud certification, you're comparing it to AWS, just Azure, right? Let me know, and we can also tell we can tailor that for you too, right? So sometimes, in these specific scenarios, right? You wanna scale infrastructure. And these are some common sales tactics when end users are trying to sell the product. And in sales, um, you'll have the objection like, "Hey, Google Cloud sounds powerful, but I'm just starting. Is it too complex and expensive for small projects?" As a warrior, as a professional, Google Cloud scales with you. You could start small with minimal resources and scale only when needed. Right? You have services like serverless compute, and again, serverless compute, right? It's a compute system that is serverless. It's all code based. managed AI platforms. And that lets you avoid that heavy infrastructure setup while you're staying ready for growth, right? So you want to avoid common misconceptions. Like I want, like, for example, I want a scalable infrastructure, right? Or I need enterprise grade security. Instead of saying my AI project isn't that big yet, do I really need enterprise level security? And that's you don't really want to give that objection, right? Security isn't just for big companies. It's about protecting your data and users from day one. You have to understand, like Google Cloud provides built-in identity management, right? Google Cloud built provides encryption. Google Cloud provides compliance tools, so you don't have to rebuild your system later. Well, why not just use open source models instead of Google? Or I want access to Google's foundation models. Well, open source models are great for flexibility, but managed foundation models from providers like, let's say, for example, Google DeepMind, right? If you don't know what that is, it's an AI research laboratory in the UK, right? And they use this artificial general intelligence, again acquired by Google and founded about, let's say, 2026. We're looking at almost 16 years ago. I don't know if you guys know about Alphabet Inc. It also offers part of that too, right? The rookie sees complexity and cost. Oh, I just want to sell. I just want to, we see scalability. I see long-term strategy. It's the difference. And the difference isn't the platform, it's your mindset, right? And again, this offers that enterprise ready performance. It offers scalability, it offers security and integration with your data without managing the infrastructure yourself. Right. Before I get to the architectural patterns, I want to understand that, you guys understand what we're talking about, especially when we're talking about Vertex AI, main platform. You got to get educated. Like I said, I have this system called the iWise. It's called the iWise. You know what? Let me give me 1 second. I'm just going to open up a. Right. I'll help you. Right. This is me. I'll help you, but you have to sell. You have to build. You have to promote. You have to market. I'll help you, but you have to sell. You have to market. You have to promote. You have to build. Okay. And again, Google Cloud is one of the leading platforms. Again, there's Azure, there's AWS, different hyperscalers around here that are leading platforms for building on those training models, right? You know, you, you also have, oh, cloud sounds expensive. I don't have the big budget. It's too expensive. It's too expensive. Well, cloud, you only pay for what you use. Think about what I just said here. You only pay for what you use. You can start small, you can grow later. It's like paying for electricity. You don't pay for what you don't use. And again, people are going to object to that. Like, what about phantom power? What about phantom power? What about phantom? What about phantom power? And this isn't a course about phantom power, right? you know, you're thinking a little deeper. Good, but in cloud costs, your phantom power is paying for the resources you forgot to turn off. And as a professional, I know that. I've heard you get huge cloud bills because they forgot to shut things down. Well, what if I leave something running and it keeps charging me? Well, listen, that can happen, but only if you don't manage your setup. Remember, Google Cloud gives you the budgeting alert. Google Cloud gives you the spending limits. Google Cloud gives you the billing dashboard. Let me see if I can show you a Google Cloud platform. Google Cloud. See if I can show you the console. Gives you all the billing and stuff like that, but I need to log in. Okay. Give me 1 second. Okay, here you go. So here's the platform, right? Here's the platform. It's coming up. There you go. So this is mine. This is my platform. Pin. Separate the views. Okay. All right. So again, here's the pin button. If you guys wanted to know, you guys can pin that and customize the tool. Again, you can create different projects here if you want. I can create it. I can create a project. Very easy. You just got to know how to. I'll show you how. I'll help you, but you need to sell. You need to build. You need to promote. You need to market engineers. You need to market salespeople. Right? We can deploy. Right? We can look at the billing. We can look at the security. Right? Auto shutdown. We can look for auto shutdown. Auto shutdown. Oops. Right? Vertex AI. Here's Vertex AI. Here's the dashboard. I was just talking about Vertex AI. Right? Again, usage reports. We can do the usage reports. No problem. No problem. Right? And us as a warrior, we check their dashboard. Your rookie ignores it. Ignores it totally. Right? Cloud doesn't secretly steal money. It doesn't secretly steal your money. It charges for active resources. If something is running, it uses power. It's using power, right? Again, remember, phantom power, you're paying for resources you forgot to turn off. Right? Rookies, cloud isn't risky, right? Or even if you're a prospect, the warrior mindset, cloud requires responsibility. It's like leaving the lights on at home. Electricity isn't the problem. It's forgetting that is. Right? It's like leaving the lights on at home. Electricity isn't the problem. Forgetting it's what's the problem. Right? You can avoid surprise bills, right? You can avoid big cloud billing mistakes. And we can, with zero risk, I can show beginners on how to safely practice with that $0 risk. That's the mindset, right? Remember, cloud doesn't secretly steal your money. It charges for active resources. If something is running, it's using power. And in Vertex AI, when we talk about Vertex AI, we talk about the different model gardens and the different Vertex AI Studio, right? When you select a project, you select your quick project, right? I'm not going to create the project for you, but again, I'll show you, I'll help you, but you're going to have to build it, right? Different AI ML models, right? Creating the project. Let's go, right? Whatever you want to do. Cancel. Storage. Create a project, right? You got to start your projects. You got to select the right project. You got to start the project, right? And there's different patterns. Like I said, when you're creating these, you have to understand that there's different patterns for these architectures that you want to build, right? Don't just go ask Gemini for help. A human still needs to go in there and do that. You need assist? No problem. There's your assist, but you still need that human interaction. You want to learn about Gemini Cloud Assist? Here you go. Then we have our posture management, our security, our policies, our marketplace, where we go in and we buy specific things. Okay. So that's like I said, that was, if we go to Vertex AI, this is where Vertex Studio is. This is Agent Designer. This is RAG Engine. These are Vertex AIs. This is all agent builders, notebooks. This is where you get it done correctly, right? So remember, phantom power isn't just magic. It's a virtual machine left ready, right? So there's no, you're not really, the GPUs are still active, right? The projects are actually, the test projects are forgotten, and the storage isn't really deleted. So, that's why smart users, again, when we set the billing alerts, we will know. Obviously, you want to turn off, your alerts. You need to put your alerts on. Right? Turn off your unused resources. Use your free tier for learning, right? And monitor weekly, right? So here's another one. Looks too complicated, Sal. Well, there's too many tools. I don't know where to start. Every expert here was confused at first, right? So when you go ahead and start with one tool like Vertex AI, like I showed you, Vertex AI. Start. Start a project. Learn step by step. Ask questions. You don't need to know everything on day one, right? So, you know, again, you don't need to learn everything on day one. Well, it looks too complicating. There's too many tools. I don't know where to start. Well, every expert was like myself, like everybody else that I've helped in the past. We're confused at first. You start with one tool, like I said. You start with one tool as an example. Well, I'm not a strong programmer. AI sounds too advanced. Well, Google Cloud has tools that require little or no coding here. You can still learn while building, right? And skills grow with practice. So you don't have to be a strong programmer to use Google Cloud. A lot of people do this. They have no training, but they'll use the Google Cloud Assist overview, right? And that's part of the Google Cloud portfolio, and that simplifies the application lifecycle, right? Get started. Remember, I'll help you. You sell, you build, you promote, you market. Well, what if I fail? Well, if it doesn't work, you learn. That's not failure. Okay. That's training. Every strong person or developer or architect failed many times. What if I try and it doesn't work? Again, if it doesn't work, you learn. That's not failure. Well, maybe I should use something else. Other platforms are better. Well, every platform has strengths. The smart move is learning one deeply. Skills transfer anywhere. Am I wrong? Again, there's going to be a lot of fears of people, right? So, the money objection, yeah, we can talk about anything you want, but again, it's all up to you and how you value your work and how close you need to value what you want to become, right? So we talked about Vertex AI. We're going to talk about our flagship AI models, which is called Gemini. And again, that's DeepMind owns that, right? Google DeepMind, like I just said, owns that, right? They developed that, and you can use them via the VI Vertex AI model, right? We can use that for chat box. You can use that for text generation, code generation, image understanding, multimodal apps, right? You can use that for whatever you want. All here. Okay. You can build your different agents. You can build your agent gardens, your agent engines, your tools, your RAG engines, right? Just go ahead and start it. Prepaid, pre-trained AI APIs, right? And we talked about, they offer these ready-to-use AI APIs, right? So they'll use speech to text. You can use text to speech. You can use translation AI. You can use document AI, like processing invoices, processing forms, PDFs. These require minimal setup, but it you're you're um you're avoiding the laziness. Like, don't be lazy. Okay. It also has the AI infrastructure, right? And we'll get to the AI infrastructure in a second. Right. And the AI infrastructure provides those GPUs. It provides the NVIDIA, right? The NVIDIAs. That's the GPUs, your graphical processing units. Then it provides your TPUs, right? Which is the custom AI chips inside Google's architecture. And it all depends on how you want to draw things and how you want to build things and how you want to learn it and what networking patterns that can help you meet these security requirements for your applications. You have in AI infrastructure, you have BigQuery, and that's for large scale data analysts. It makes it strong for large AI workloads. Right? And Google Cloud provides that. Google Cloud is a great opportunity to invest in, right? It all depends on how you value. Let me see if I can open this in a new tab. Oops, admin. Um, and Google console, admin console. And this is for the admin help, right? Where again, I have a video on this as well too. Oh, you guys are interested in learning that? Let's sign in here. Sorry, guys. My apologies. He's not picking it up, but let's see what's going on. Okay, there we go. But like I said, this is all all inside, right? 1 second, guys. I apologize for a second. Okay, this is the wrong. So give me 1 second. Here we go. But yeah, the admin console, same concept, right? You have your admin console, and it, see if I can log in for you guys and show you. There we go. All right, there we go. Okay, here you go. So admin console, same concept, right? Manage your users, manage your data, your right? Manage your apps. And I want to separate the view. So here you go. So again, this is all, yeah, and then there's your alerts, right? So making your mandatory service alerts, right? You can read this based on the last alerts that there was, right? You can read all that. Then you got your data, you got your security, your generative AI, right? If you're using your reports, your Gemini apps, right? Are you ready for that next step? Are you ready to expand the business as more people come? Are you ready to keep the business running and moving? Right? Right? The different apps that are involved, what I could do with those apps, right? The security that's involved for your business. So that's admin center. That's the console. That's the console, guys. Right? And these are the different apps. And again, you can arrange these apps however you want, and you could do that on your own time. Okay, so let's go back to the patterns. So again, we have our AI infrastructure. We talked about our GPUs or TPUs. We talked about our custom AI chips. And I will show you what a GPU is versus a TPU. A TPU is kind of they call it a tensor processing unit, and those are Google design. And what happens is it's designed for um, ASIC optimized. I'm not going to explain what that is, but in simplest definition, the architecture, right? TPUs use that design, right, for memory shuffling, right, and for any operation that you need. Those GPUs right there utilize they use thousands of small cores, parallel processing, and that's the system. So when you want to choose, you look at the costs, you look at the ecosystem, you want to choose a TPU or you want to choose a GPU. TPUs you want it for larger scale trainings, especially when you're using TensorFlow and you're invested in the Google Cloud ecosystem. Yeah, or use GPUs in your system or when you're choosing, right? And you're using that for like AI models, premises hardware. So make sure that your systems are in place. Okay. You want to use TPUs? Go ahead. But remember something, you're using it for scaling neutral network training models, right? So your LLMs, your large scale. You can use it for high volume or interference, especially within the Google Cloud platform, right? You you can also, you know, it also has its advantages, right? So it has the higher performance per watt. So basically, it's got two to three times better per watt performance per watt. It's specialized in array design. Let's just all. I'm not gonna explain all that to you, and it reduces memory bottleneck. Right? It's knowing what the difference is. It's knowing what the difference is and what's better for AI, right? Especially in your AI projects. You need to know what's better, right? You need to know why, like what is better, like why, like what is TPU versus NVIDIA GPU. You need to know your takeaways instead of just using it because it's easy, or I use this to make money. Look at the performance, look at the takeaways. You know, when you're comparing TPUs and GPUs, especially through speed or throughput, matters like especially speed and throughput. That matters the most for any workload. So if you're buying something, make sure you're ready for that. You know, GPUs, I think they use 300 to 1,000 watts for GPU, especially in power usage, and when you're comparing power consumption. And I think a TPU uses 175 to about 250 watts. Right? That tensor processing units, the TPUs, tensor processing units, TPUs, right? They use less power than any graphics processing unit, GPU. So what that means is lower costs than heat. A TPU will help you run large-scale API projects while your GPU remains more powerful. Yeah, it needs more energy, 300 to 1,000 watts. And a cooling system like that. You need a great cooling system. You need something that's more advanced. You can use dynamic voltage and frequency scales. You can use techniques like dynamic voltage and frequency scaling to optimize GPU, the to optimize your GPU, your company's GPU. So you get more performance, right, per watt with the TPU versus the GPU, especially when you're trading. That's just more for the trading performance, right? And you have more like the TPUs itself, the tensor processing units, they reduce your energy bills and especially carbon footprint when you're scaling up an AI workload. Right? You want to talk about scale? Again, scale. NVIDIA uses quantum. It's very expensive and it has very complex cabling. Right? You're looking at NVIDIA excellent, but it's pricey. Whereas your TPU, your tensor processing unit, scales at 110,000 plus chips. And that's okay. That's okay. Right? You got your NVLinks and you've got your Quantum 2. Again, this is all in framework. Remember, you're using a TPU for Vertex AI. You're using your design has to be as ASIC. Your integration has to be heavily in Google Cloud, and your dynamic needs to scale. Has to be optimized for scale, right? Whereas your NVIDIA GPU scales with flexible orchestration, right? So like I said, it's all in your design. It's all in your design. So let's get back to the design aspect. I'm not going to talk too much about this, but you guys kind of get the gist of it. And when we look at the different patterns for especially for a hybrid and cloud secure, we're looking at the different patterns here, right? And in this document here, um, you know, the patterns should be incorporated into the organization's landing zone architecture, right? So that's included multiple networking patterns. That's included in address specifications, communications, et cetera, et cetera. We look at the first one, architectural pattern. We look at the mirrored pattern in your hybrid multi-cloud. Now, what is a mirrored pattern? Right? It's based on replicating the design of an existing environment or just environments to a new environment or environments, right? So you're replicating the design, right? You're mirroring it, right? Based on the design of a certain existing environment to a new environment. So that pattern there applied to architectures that follow the environment hybrid plan. Make sense? So sorry, environment hybrid plan. Let's see. Now, with the environment hybrid plan pattern, you can keep production environment of a workload in the existing data center. You then use the public cloud for your development and testing environments and other environments. This is a pattern. It's a pattern. Right? So here's the pattern. Right? You have your development environment and you have your production environment. You have your test environment. You have your, and in this one, you see, as you can see, you got your front end and you got your two back ends, backed up by your two back ends, right? And your development, and then that development life cycle is what your production environment is going to see, right? So you can run development and test systems in different environments, and then your production systems might seem risky and could obviously they could deviate from your existing best practices. But um, what you need to do is use it for use the public cloud for your development and testing environment. So that pattern again relies on the redundant deployment of the same application. What does that mean? Okay, so if I were to break this down, you have a playground, right? So this is your playground. Let me see if I can grab. Anyway, I don't have a pen, but as you can see, you have your blue area here. That's a playground, and where you this is where you test and practice your games. So you have your development and your staging. And this one here on premises, right? That's where the big games for everyone, for the big people. This is where you do the real big games for everyone, right? So this is where your whole city comes in, or your whole company comes in. And at that point, the mirrored pattern is like copying the exact layout and rules of playground one into playground two. When you practice, especially this way, when you practice on playground one or this cloud, this development environment, you'll know I work the same way on playground two. Remember, it's separate but similar. You don't let kids from playground one and playground two play together directly. But both playgrounds look and feel the same. So practicing it in one helps you succeed in the other. You get what I'm trying to say? So practice in one will help, and that'll help you succeed, right? And that's the development life cycle, right? We can manage everything consistently. You may want tools like let's say for example, let's stick with the playground here. Like your coaches, your referees, your school boards to work in both playgrounds in the same way, right? We talk about communication that's controlled. Now, if the kids need to pass messages between playgrounds, it has to be careful. It has to be controlled. There isn't any random shouting it across the fences here. Simple, very simple. Imagine you have a robot, okay? And this robot coach, and this is when we talk about updates and checks, right? So you have an automatic update or just a check in general. So imagine you have a robot coach, and that updates rules, watches games, and fixes problems automatically in both projects or programs or playgrounds. That's like CI/CD monitoring or CI/CD, right? Or monitoring or just the configuration management in the cloud computing, right? just you can test safely without breaking the real game. And you're making sure that what works in testing will work in production. And that'll help you organize and control big systems safely. Right. Again, when we use specific words, yeah, that are tricky, it's okay. But again, try to pronounce the words, especially in your delivery, right? And or whatever expectations that you have out of this, coming out of this. Okay, well, for example, let's get back into the sales aspect of it, especially when you want to sell this environment or you're trying to sell this environment. Why bother copying everything to another environment? Isn't that a waste of time and money? You'll get these, scenarios, and can we just test and run everything in one place? How do you respond to that? Well, if you do everything in one place, mistakes in testing can break real systems, right? And using our mirrored pattern, right? Using our mirrored pattern here, let's say, for example, this is our mirrored pattern, right? It'll show a high level reference architecture, right? And this is our architecture for that. But again, using that pattern keeps testing and production separate, but it's consistent. Okay. You're directing the traffic, right? You know where the direct traffic is allowed versus where the direct traffic isn't allowed. You still know your work will run smoothly in the real environment, right? So without risking a big mess. And that's like practicing your game on one field before playing the championship on a real field. If you don't practice it, right, you'll never get it. It costs too much. Okay. Well, making two identical environments, yeah, it may seem expensive. Why spending extra money just to copy things? Yeah, it costs a bit more upfront, but it prevents a bigger disaster later, right? So a mistake in testing won't crash the real system, right? You're saving time and money in the long run. Remember that. You're going to get these objections. Well, managing two environments sound confusing. I might mess something up. You could start small and use automated tools, right? As an architect, I would normally, work with the developers and coders and start small and use automated tools. So CI/CD and monitoring help keep both environments in sync automatically, so you don't have to do everything manually, right? That's true though; it's not complicated. And I want to explain what CI/CD is to you guys, and it's called continuous integration and continuous delivery or deployment. So it's basically software deployment. And I don't design this by architecture, right? I'm an architect. I design for you, and then I hire other people to do it for me. But again, remember something, especially as a CEO of my company, you know, I'm supporting your company in a way that your delivery is ready for release or just automatically deployed, especially when you're deploying that to production. And again, CI developers frequently merge code into shared repositories, into shared storage, and that triggers the automatic builds and that tests to identify bugs early. But then you have your continuous delivery. Those are your different types of delivery, right? Your integration, your delivery, your deployment. And that's what CI/CD means. Right? This is where your developers are going to merge the code, right? This is where the integration is extended into your test, right? So that your application is ready to go, right? Then you have your peering, then you have your shared VPC, right? You have your development subnets. Again, that's all networking. Again, that's a different aspect. But when you're looking at these different architectures, you need to understand that you know these are high level reference architectures, right? So it's your integration, your CI, your delivery, your CD, or your continuous deployment, CD also, right? And that'll go further than any delivery. What else do we need to talk about? There's benefits of CI/CD. Again, I'm not a developer or programmer, but there's different pipelines like Jenkins, GitLab, AWS uses code pipeline. And again, I'm not too sure what Google uses, but I think Google Cloud. What do they use for CI/CD? They use a serverless platform. It's called a serverless platform. Right? And we can test on that CI/CD platform if we want. If you want free credits, send me a message. I'll teach you how to get it and how to test on this environment for free. Right? You can build on there. You can program your languages. You can choose from 15 machine types. Right? You can choose from these 15 different machine types. Right? So in Google Cloud, we call it a compute engine machine type. So if you don't specify the value, the cloud builds the default value of an E2 medium. I'm not talking about machine types now, but have an understanding of what that means first, right? Your E2 medium, standard. Again, these are all different types of machine types by region. So it's also the region that you need to understand. Then you have your N2Ds and you have your C3s. Okay? So when we're looking at the different machine types, you have your E2s, you have your NTDs, and you have your C3s, right? So this is all based on region. And make sure you're using the right one for the region that you're using it for, because that is important. You can also write private pool configs. Simple to create, manage private pools. Again, coding. This design here is meant for you to build this, right? So we can build this for you and design this for you based on your needs. You might also want to know about firewall rules. You want to know about the VCPs using the internal IP addresses here, your VCP peering. You have to set that up as well too. Know how to set that up. And again, this is all established through a hybrid multi-cloud network connection, right? Just make sure that your RFC 119 1918 IP address space is used, especially in your networking. Okay, let's see. Right. So you are using your address spacing here, right, for that address space. So make sure that you're using this address space. And this is the where you would get your information from. Usually get it from the IETF, right? This is where your private spaces are versus your public spaces are. Okay. It sounds confusing, but it really isn't. You just need to have the right design in mind, right? And choose and build and deploy this, right? Again, let me know. I'll set you guys up with $300 in free credit to spend on cloud build, and you'll get 200, I think 2,500 build minutes free per month, not charged against your credits, right? So let me know. I'll set you guys up on that, and again, I'll show you the key features, the customers. I'll get you guys running on that, right? You can access these machines uh, in Google's global network, right? And this will reduce your build time, right? A run built on a high CPU VM or cache source code image or other dependencies, right? This will further increase your build speed. So CI/CD, I explained to you already, right? Again, it costs, yeah, it costs a bit more upfront, but it prevents bigger disasters later. Right? You're gonna have a lot of disasters happen if you don't do it right, and a mistake in testing won't crash the real system, right? So make sure that you have that set up. The two environments, right? You have your test environment, you have your in production environment, and right. So start small, use your automated tools. We talked about it's not complicating, especially when you're managing two environments. It sounds confusing, but and you might mess things up. Well, make sure that you guys build. I'll help, but you guys have to build, sell, promote, and market that, right? The system, yeah, copying environments takes forever. It won't slow down environment. It's not just about copying and pasting. It's not just about asking ChatGPT to build it for you. It's not. You don't ask ChatGPT to build it for you. You don't ask AI to build it for you. No, you build it yourself. So again, here's 19. That's the private addressing spaces. Make sure you guys have that down packed. Right. So this is our mirror pattern. Right. We can talk about where this is the different design requirements and their variations, right? You can talk about the hub and spoke topologies. You can talk about the microservices zero trust distribution architecture, right? We can expand that, right? Especially when we're talking about shared VPC in this environment. This is where we want a shared VPC in vPeering, right? So this is our design. I want you guys to build that. But just make sure you have your two environments. You know, copying environments, yeah, it takes forever. It won't slow down. Once the setup is automated and ready to go, deploying updates become faster, right? Deploying those updates become safer. So in the long run, it saves more time than costs. So if you ever have somebody say, "Hey, it won't slow down development," yeah, at first, but once the development is automated, right? You're going to automate it. You're going to get your team to automate it. Deploying your updates becomes faster and safer, right? So in the long run, it saves more than it costs. So just think about that way. And again, we can create, we can talk about, debate segments. We can talk about, you know, if we have two identical environments, um, in an objection, you could say two identical environments sound expensive. Why spend extra money? Well, it may cost more upfront, but it delivers bigger disasters later, right? So a mistake in testing won't crash the real system. That saves money and stress in the long run, right? When you look at the objection, the complexity, you have your automation tools like CI/CD, like I said, right? And monitoring keeps both environments in sync. And I showed you the picture before. I showed you that picture before, right? The two environments, your test environments. right? Your two test environments, your CI/CD and admin VPC, right? You're keeping the on-premises private environment and you're keeping your Google Cloud environment separate. And once it sets up, it's actually easier to manage and doing everything manually, right? You're going to get complexity questions, right? So automation tools like CI/CD and monitoring keep both environments in sync. Once it sets up, it's actually easier to manage, right? But you're going to get a lot of people. Okay, so how do I actually close this? See, with the right tools, complexity becomes control, right? It's like setting up a remote control. At first, it seems tricky. Once it's programmed, everything runs smoothly, right? Just remember something, right? You know, complexity, turn it into control with the right tools. Safe practice today means smoother games tomorrow, especially when you're talking about why not just the test in production carefully? Well, no, you got a safe practice today, and that means smooth games tomorrow, right? So testing in a production is risk in production is risky. Wrong move may break everything. What about cost? Well, making two identical environments, yeah, it sounds expensive. Why spend the extra money? And you're going to get this objection all the time. Oh, it may cost more upfront, but it prevents disasters later. A mistake in testing won't crash production, right? You're not going to crash this production. Give me 1 second. 1 second, guys. So if I were to take this, and again, when you're designing this, you're using their proprietary pictures, right? Um, Especially in this scenario, right? Because we're talking about this picture here, this architecture, and this architecture talks about CI/CD here in this instance, where there's direct traffic allowed, right? And then you're using a VPN or a cloud interconnect in between the two, sort of like your transit gateway between the two, and you need to understand that because especially when you're running these projects. Let me get a. Here you go. Okay. So you know think about the CI/CD here, right? Right, and the direct traffic in between them that's allowed. So there's incoming traffic allowed or direct traffic going through this cloud VPN or cloud interconnect, right? And that's going from your production environment through to the cloud, right? Especially in a real environment. So you don't want to let the direct traffic through the VPC, right? Especially in your projects, right? So if you have a project here where you have a shared VPC pairing between the two, um, and complexity in the CI/CD tools, right, keeps both environments in sync automatically. So having those automation tools in your design in your design, right? Your network design, inside your work design, right? Is important on both environments. So you need to have them on both environments, especially when you're migrating the data through them, right? You know, in separate environments, they say, no, it's not needed in separate environment. Well, yeah, it does. You need it. You just need to test it carefully. That's I get these objections all the time. Oh, but the rules are restrictions, right? That's a communication restriction. Rules aren't restrictions. They're just helping you protect your system. They're shields protecting your system. They're shields protecting your system. Right? These are different patterns that you're going to see in architectures. And, you know, looking at these different patterns, you need to understand what traffic is coming through and what's not allowed and what's allowed in between your environments. It's not just designing and think you did it and write a bunch of lines of on a piece of paper that you just typed out. And this is what an AI model looks like here. This is another concept that I want to talk about. I could talk about this in another video, but I just want to use this example for your Google Cloud um, environments in a mirrored architecture because I think a lot of the times people will mirror things, right? Different patterns, mesh patterns. We can look at the different mesh patterns, right? When you're considering designing in a hybrid or a multi-cloud, right? So going through this list here is important, not just scrolling through and knowing what each thing does, right? So that's your mirrored pattern. Again, different scenarios. Well, okay, say for example, I wanted to close this deal. Okay. And we'll go to the mesh pattern right now. And I want to set up kind of a role play scenario where, I want to close this deal. Right. You're a cloud solution sales rep. You're talking to a client and you're hesitant about adopting this pattern for your environment, right? You want to buy this product, right? So you have our rookies, our clients, skeptical, unsure, worried about the cost and complexity, and you're worried about the sales professional warrior, right? And me as a warrior, we speak confident. We're explaining benefits clearly, and we close the deal. Remember, don't just watch this once and give up. Watch this 2 or 3 times. Take notes. You know, I've been spoon feeding a lot of you guys, giving you a lot of guys the notes and attention. And sometimes it's okay to learn this stuff on your own and read it twice. Right? I don't know. So I want to get into this kind of professional idea of selling this mirrored pattern. And making two environments, like if I'm the client, for example, I'm the client, okay? I don't know. Making two environments sound expensive. And managing them seems complicated. Can we just test it in production? Remember what we talked about. I understand your concern. It's normal to feel that way. Let me break it down. Give them assurance of what you're going to tell them to do. And like I did in my area, I explained to you, I showed you, right? With the mirrored pattern, your testing environment is a safe copy of production. Your testing environment, say, for example, this is your testing environment. This is your testing environment. Let's say, well, that's really Google Cloud, but you have your testing environment, and then you have your on-premises environment, right? You're on in production, your production environment. So you have your production environment right here too. This is your production environment, right? And this is your test environment, right? As an example, not to get confused, but it's not confusing. It's pretty straightforward. Um, With this mirrored pattern, right, of making two environments, it's a safe copy of production. That means that you can try new updates and features without risking for your real users, right? And mistakes in testing won't break production. So, plus tools like CI/CD, like I told you before, the CI/CD automation, right, makes managing both environments much easier, right, than it sounds. So think of it as having a remote control. And I talked about the playgrounds earlier, about managing both playgrounds. Once it's set up, it's smooth and stress-free, right? And then you'll get your client or prospect. Okay, but what happens? What about setup time? Won't it slow down everything? The first step takes a little effort, but yeah, after that, deploying updates and managing workloads become faster and safer. You have more time than you spend, or you prevent costly downtime later. Think about it. You have more time than you spend, or you prevent costly downtime later. Like the first step takes a little effort, yes. But after that, deploying the updates, manage the workloads. And that becomes faster and safer. You save more time than you spend, and you prevent costly downtime later. So it's really about the long term. Okay? And you're investing a little now to avoid a major headache and cost in the future. Again, this to me, I would grade that a B. If you want to look for an A grade type of solution, you're a closing solution, I would say setting up Google Cloud's mirrored environments take a little work at first, but once it's ready, updating and running your apps becomes much easier and safer, right? So you actually save time instead of wasting it. So this will help you avoid big problems in the future. Simple, right? Think of it as like building a practice playground first. You can try new things safely before the real game. So a small effort now keeps your systems running smoothly for a long time. Very simple, easy to understand what I just told you. Very simple, right? I'm talking about the playground. I'm making a technical concept. It's visual for you guys. I have my design here, right? Use short sentences if you have to. Sure, no problem. You could talk about. We could discuss each version for you, just in case you have questions, right? Summarize what you're going to say. Summarize and present what you're going to say. Bullet points, right? You know, questions that you can ask, like, oh, what does a mirrored environment in Google Cloud help you do? Can you think of an example where not testing safely first causes the problems? So, we can answer these questions based on what you already learned today. And yeah, what does the mirrored environment in Google Cloud help you do? Well, it helps you copy your testing environment, right? To match your production environment. Remember what we talked about earlier, quizzing you. So you can safely test new features, right? Updates, or even apps without breaking the real system, right? So it's worth your time. You have to understand, like, it's not about, like, if I'm a cloud solution sales rep and I'm talking to the client, right, and I'm adopting this mirrored pattern for their client, yeah, they're gonna feel skeptical. They're gonna feel unsure. They're gonna feel worried. They're gonna worry about cost. They're gonna worry about complexity, right? Oh, how is the mirrored environment like a practice playground? Well, lets you try new things safely before the real game, right? So similarly, a mirrored environment lets you test the apps and updates before applying them in production. Another question: what are the long-term benefits of using mirrored environments, right? Oh, you're talking about predictability. You're talking about system reliability. You're saving time management apps. Saves you time in managing apps and those updates. You're not reducing the risk of breaking production. You're in production environment. Another question. Can you think of an example where you're not testing safely first could cause the problem? Updating a website without testing could crash it for users. Adding new features to an app without testing might cause bugs or just even data loss. Changing the company system without a mirror could interrupt worker services. Right? Mirrored pattern. Well, I think we're out of time right now. So I want to wrap it up. I'll talk about any pattern you want. Just let me know. Or if I get enough likes, I'll create a part two. So to wrap it up, Google Cloud mirrored environments in this example of hybrid and multi-cloud architecture patterns, right? For networking, this is the network architecture, the networking architecture, right? And then we have our architecture patterns, different patterns, right? Our edge pattern, or again, we'll talk about this at another time. We could talk about gated egress, gated ingress, these are all the designs that I want to talk to you guys about and different objections that you'll get on that. Um, you know, to make the delivery smooth in your environments, you need to execute, right? It may take a little work to set it up at first, but that time or effort saves time. Keep your systems reliable, right? And that'll protect your user. Think of it as a practice playground. Again, like I said before, you try things safely before the real game. You try things safely before the real game. You start the plan. You start smart. Plan ahead, and your cloud system will run smoothly for a long time. See you in the next one.